When you look at equilibrium constant expression, here this is the expression for this equation. H2 plus I2 are the reactant, this is the product. So the product concentration comes on top and the reactant concentration comes in. This is, let's say this. Now, if you see the reverse, that means treating this as the reactant and breaking down into this. Then you get this as the product's concentration on the top and this. So this is 1 by Kc. So the equilibrium constant for this reaction is the reciprocal of the equilibrium constant for the reverse reaction. You might feel that both of them are the same thing, but you should understand we are looking at from this perspective, from this breaking down into this. Here we are looking at this adding to get this. The other thing we have to also consider is if we change the stoichiometric coefficients, like you divide, then the equilibrium concentration will become raised to power half. So in that case, it will be so half of this. So the Kc for this H2 plus I2 is raised to power half is equal to the Kc for when the stoichiometric coefficients are hard. Now, please see this A, B, C, this is Kc. A, if you see the reverse, it is 1 by Kc. And if you divide it by some multiple of n, the stoichiometric coefficient, it becomes the original Kc raised to power n. Then we also consider in terms of gaseous. Gaseous, the concentration. This is the concentration, moles per unit volume. So we can write partial pressure as the concentration moles per into RT. So generally we use the partial pressure here. And if the partial pressure and concentration will be same if if it cancels out, like here it is, this is partial pressure of HI whole square is this into RT. So if you square this, RT square comes on top and below RT and RT come. So they cancel. So the partial pressure and Kc are same. The equilibrium constant in terms of partial pressure and equilibrium constant in terms of concentration are same. But sometimes they're not. That depends on the number of moles. Like if it's in a Haber process, I write the concentration RT square, the partial pressure of ammonia over squ- uh, square over partial pressure of nitrogen and partial pressure of hydrogen raised to a cube. Then RT cube. In this case, what will happen? This will convert to RT minus 2. And actually, the Kc into RT minus 2 is Kp. So it depends on the reaction, the number of moles. This is the formula where delta N is the number of gaseous products, moles of the products minus. So you can give the answer in terms of Kc or Kp. Kp and Kc are related equal in some cases, in some they are related by this when the number of moles change. If the number of moles are same, then the Kp and Kc are same. Otherwise, they are different. And of course, the units will also be different.